Very good morning, friends. Today we will see the problem on the last topic, that is collision on elastic bodies. Right. So that is our impact on elastic bodies. So in this topic we will have a problem. So we have seen two equations. One is coefficient of restitution. What is that? That is velocity of separation, that is relative velocity of separation by relative velocity of approach, that is v2 minus v1 by u1 minus u2. That is one equation we have seen. Then conservation of momentum of bodies, both the bodies, MAVA is equal to, that is m1 v1 is equal to m2 v2 is equal to m1 v1 plus m2 v2, that is momentum before impact of the both the bodies, summation of both the bodies is equal to momentum after impact the both the bodies. These two equations we know. Apart from that, we have seen one more equation. If it is a perfect elastic body, the coefficient of restitution will be equal to 1. If it is a perfectly plastic body, the coefficient of restitution will be is equal to 0. Right, using these equations, we will see these terms, we will see the problem, how to solve a problem. So you look at the problem. Here I have body A. I have body A. I have body A having a mass of 12.5 kg. Body B having a mass of 25 kg. Body C having a mass of 50 kg. So body A is moving at a velocity of 60 meter per second. Body B moving a velocity at 4 meter per second. Body C is moving at a velocity of 3 meter per second. So three bodies are moving on a right side. So it is in a positive direction, the three bodies are moving. So if the body, any body is moving on the left side, you should remember this is our note. If the body, any body is moving on the left side, you have to take the velocity of minus 4 or minus 16 or minus 3. So here all the bodies are moving on the same direction, on the right side direction. So on the right side direction it is moving. So the first body is having more velocity, second body is having lesser than the first body velocity, and third body is having lesser than the velocity of the second body. So what is, if it is a perfectly elastic impact, what is the final velocities of the bodies after impact? That is the question. So here you can see body A is in 16 meters per second velocity, body B is 4 meters per second. This is 3. First, it will moving, the body A will be moving very fast and it will hit the body B. Then body B will goes and hits the body C. So two impacts are happening here. So you should be very careful. First, we will take the first impact, that is body A and B, which is having 16 meter per second velocity and 4 meter per second velocity. So I have considered the very first impact, that is within the body A and B. So body A and B, you know the masses and velocities. So using law of conservation of momentum, so you know the equation of momentum equation, that is MAUA is equal to MBUB is equal to MAVA plus MBVB. This is one equation. Using this, I will substitute mass of A is 12.5, this is 16, this is 25, this is 4, and this is 12.5 mass of A, and VA we don't know, 25 VB we don't know. So we will be having an equation by whole term I can divide it by 12.5. 12.5 if I divide it, here I will have 16, here I will have 2 into 4, 8, 16 into 8, 24. 24 on the right side, here 1 VA plus 2 VB. VA plus 2 VB is equal to 24. We have got that. This is the first equation using the conservation of momentum equation. Then you know one more equation, as I told, that is Coefficient of restitution. Coefficient of restitution is equal to 1. E equal to 1. Since it is a perfectly elastic body, elastic impact. So that is Vb minus Va by Ua minus Ub. So already we know the equation as V2 minus V1 by U1 minus U2. That is initial velocity minus, this is all the final velocities, this is initial velocities. So Vb minus Va, we don't know, that is the final velocity of the bodies, but we know UA minus UB. UA is 16 meter per second and UB is 4 meter per second. This will be 12. 12 we will be taking to the side, and 12 it will be VB minus VA equal to 12. So this is my second equation using the coefficient of restitution equation. So now by solving this 1 and 2 for two unknowns, you will be getting VB is equal to 12, VA equal to 0. That's what the final velocity of VB, body B, is 12 meter per second. It will be moving by 12 meter per second, and VA comes to rest. That is, body A comes to rest. So this is the first impact. Now in the taking the second impact, that is body B and C, we will consider it as again A and B, right? So here now the body of previously it was in the original condition it was in 4 meter per second. After collision it starts moving with 12 meter per second. This comes to rest. So this is 12 meter per second is going to be its initial velocity. Now for the second impact it will be moving 12 meter per second. This is 3 meter per second. Then it will go on impact. It will go and hit the body C. So that is the second impact I am going to consider. The second impact you can take, you can see that is B and C, body B and C, that is 12 meter per second, and this is 3 meter per second. Again it is moving on the positive direction. So this is higher velocity, it goes and hits the C. So it is 25 into 12. This mass of B is 25 and 12 is the velocity. Mass of C is 50 and this is 3. So here it is C, B and C. So this is B and C. So velocity of B plus 2VC, it will be equal to 18. So I will be dividing the equation, previous equation, conservation of momentum equation by divided by 25. 25 if I divide it, I will get 12 plus 6, 18. So it will be VB plus 2VC is equal to 18. That is my first equation for the second impact. Then we will consider the equation of coefficient of restitution. What is that? It will be VB minus VC. This is VC minus VB. UC minus UB. Initial, sorry, there will be a mistake. As we will consider, that is this one, V2 minus V1 by U1 minus U2. So you don't get confused with A, B, C. So this is in this impact V2 is final velocity is V2, that is VB, minus initial velocity, that is VC. Initial velocity is VB, right, divided by VC divided by VB, that is V2 minus V1 divided by U1 minus U2. U1 of this impact is 12 and U2 is this impact is 3, right? So you will be getting VC minus VB is equal to 8. Vc minus Vb is equal to 8. So this is my second equation using the equation coefficient of restitution. So by solving this one and the previous conservation of momentum equation, I will get Vb is equal to, that is Vc is equal to 9 meter per second square second. Vb is equal to, I will get it as 0. So here also the second body comes to rest. Vb is equal to 0. And the third body moves with a velocity of 9 meter per second square second with the by keeping Vb is equal to 0 and Va is equal to 0. So in this impact, two impacts are happening. In the first impact, you are getting the first body as going to be rest, and in the second impact, the second body is going to hit the third body. There, and the second body comes to rest, third body will be moving with 9 meter per second. So here you can see the first impact, you will be getting one velocity, final velocities. That final velocities, you have to keep it for the initial velocity for the second impact for body B. That is one thing you should remember. Thank you.